Good morning, good evening, good afternoon, boys and girls. So today's lesson is about IPv6. Do not worry about it. It's actually very similar to IPv4, except that we are working with a different format, but we are going to become familiarized with IPv6 in the best possible way. So let's get to it. As the internet grows rapidly, IPv4 addresses are quickly approaching complete depletion, although many organizations already used network address translation is for translated private IP addresses into public IP addresses. We have to be prepared just in case they are exhausted. IPv6 was created by the Internet Engineering Task Force, IETF, a standards body as replacement to IPv4 in 1998. Now, some of the main differences is that IPv4 has 32 bits, a total of 2 to the power 32 unique addresses, and in fact, about 3.7 billion addresses are assignable because of IPv4 addressing systems separate the addresses into classes and reserve addresses for multicast, testing, and other specific uses. Now, the main difference comes that IPv6, and I'm going to highlight it, IPv6 uses up to 128 bits, which it provides 2 to the power of 128 addresses and approximately 3.4 multiplied by 10 to the power of 38 addresses. Well, maybe we should say it extremely huge. Now, when it comes to, and I'm going to move my video just a little bit, I need to use the pencil so I can highlight some things here. If we're talking about IPv6 address types, we have unicast, multicast, anycast, and they have a description for each of those. So let me just go over it. I'm going to use a different color, maybe a pink one over here. I'm going to do a little trick. So, unicast, one-to-one, global link local, site local, an address destined for a single interface. Multicast, one-to-many, any address for a set of interfaces delivered to a group of interfaces identified by that address replaces IPv4 broadcasts. And finally, we have anycast, one to nearest, allocated from unicast, delivered to the closest interface as destined by the IGP. A single interface may be assigned multiple IPv6 addresses of any type: unicast, anycast, multicast. Note, and this is important to remember, there is no broadcast address in IPv6. So keep that in mind. Why is that? So you can ask, all right, Caesar, why we don't have broadcast in IPv6? Well, the multicast one-to-many does the function and replaces the IPv4 broadcasts that we used to have. Now, there is a specific format for those addresses. I'm going to change to yellow for a moment. IPv6 address format, and you can see it there with all the X, where the X is a 16-bit hexadecimal field and the X represents 4 hexadecimal digits. This is an example of an IP address. Look at that. Beautiful, right? We are going to learn later how to summarize that IP addresses, these specific IP address correctly. Now, there are 8 groups of 4 hexadecimal digits. Each group represents 16 bits, 4 hexadecimal digits by 4 bits, separated by a column. They are separated by a column. The hexadecimal digits are not case sensitive, so DBCA is the same as DBCA in lowercase or uppercase, or they can mix lowercase and uppercase letters. IPv6 128-bit address contains 2 parts. The first part, 64, is known as the prefix. The prefix includes the network and subnet address because addresses are allocated based on physical location. The prefix also includes global routing information. The 64-bit prefix is often referred as the global routing prefix. The last 64 bits is the interface ID. This is the unique address assigned to an interface. Note: addresses are assigned to interfaces, network connections, not to the host. Each interface can have more than one IPv6 address. Now, let's move on. Rules for abbreviating IPv6. And this is what I was talking about before. I'll tell you we will be learning how to summarize them. The leading zeros in the field are optional. So this one, you can see that this IP address can also be written as follows. All of these zeros there can be abbreviated to column 0 column. And this 0 is removed totally. You saw there? That one? You see? All of these. And this one is removed. And this is all only column, 0 column, and then the rest. That's the first abbreviation. The other one, this other 0 has been removed. We don't see it there any longer. And these 3 consecutive zeros are abbreviated. They are summarized. Okay, and then what is it called? What is this rule? Successive fields of 0 are represented by as column column, but only once in an address. Okay, this next example, if you look, we have 1, 2, 3, 4 consecutive blocks, and then 3 zeros over here. This is what happened. We can do this only once. These are removed and changed by a column. These two are also removed and changed by a column. These 2 columns represents a total of 4 blocks, and the 3 are removed and we have a single one. You see the way we did it? Let's take a look at other examples. Okay, this one, you can see it there, is another example. And if you take a look, the original version and the abbreviation. Original version, I'm going to use yellow for the abbreviation. It's pretty much practice. Let's go again. Original version is equal to, and then we will get the abbreviation. Pretty much we are removing the zeros that are not necessary. Also, there is another option. So this one has a total of two abbreviations. Okay, now what else? What else do we have? Okay, look at this one. It's very interesting. We are removing pretty much all zeros, column 1. This one is pretty much converting all these zeros in column. As those are the main examples, so you can become familiarized with IPv6 and how to do the summarize of the IPv6 address, or what we have known already, that is abbreviation. Let's move forward. Now, IPv6 addressing in use. IPv6 uses the slash notation to denotate how many bits in the IPv6 address represent subnets. The full syntax of an IPv6 is as follows. We have the IPv6 address, the prefix len. Okay, there you have it. IPv6 address is a 128-bit IPv6 address. The prefix length is a decimal value representing how many of the leftmost contiguous bits of the address comprise the prefix. Let's look at more examples and analyze them. So this is an example. Now we can have the extended version right here. Look at the zeros and the word they changes. Look at that. That is without the abbreviation, with no abbreviation. The first 64 bits is the address prefix. The last 64 bits is the interface ID. So let me erase that just for a moment. And let me just do a drawing. So until this point, we have the address prefix. Then furthermore, we have, what is it? The interface IP. 64/64 is the prefix length. Prefix length. And /64 is well known, and it is also the prefix length in most cases. Let me erase this one. It's too powerful. Let's use a yellow one. Okay. In the next chapter, we will understand more about each prefix of an IPv6 address. The Internet Corporation for Assigned Names and Numbers, ICANN, is responsible for the assignment of IPv6 addresses. ICANN assigned a range of IP addresses to regional Internet Registry RIR organizations. The size of address range assigned to the RIR vary, may vary, but with a minimum of a prefix of 12 belongs to the following range: 2000::4/12 and 200F column FFFF column FFFF column FFFF FFFF column 4/64. And there you have it. What we have here is the registry, the ISP prefix, the site prefix, and the LAN prefix. There you have it. Each ISP receive /32 and provide a /48 for each site. Every ISP can provide 2 to the power of 48 minus 32, which is a total of 65,536 site addresses. Note, each network organized by a single entity is often called a site. Each site provides /64 for each LAN. Each site can provide 2 to the power of 64 minus 48, which is 65,536 LAN addresses for use in their private networks. So each LAN can provide 2 to the power 64 interface addresses for host. Global routing information is identified within the first 64-bit prefix. Note, the number that represents the range of addresses is called prefix. We have a /34. Let me just do a major change over here. There you have a /32/32. Then you have the regional internet registry RIR connection to the site. Look at that, it changes from 32 to 48 through the ISP. You have the /64 for the LAN, local area networks, for those LANs. We have a local area network here and another one over there. Now, let's see an example of an IPv6 prefix. What do we have here? 2001, column 083C, column 5437, column ABCD, column /64. Now, let's divide everything in chunks, in segments. First, we have the rear over there. Then you have the ISP. Then you have the site. Then you have the subnet. Now, what else do we have in this map, in this scenario? Okay, let me just erase a little bit. And we have now the following. A global prefix ISP assigned where we have the rear, the ISP, and the site with their different prefixes, and a subnet, which is column /64. In this example, the rear has been assigned a 12-bit prefix. The ISP has been assigned a 32-bit prefix, and the size is assigned at 48 site ID. The next 16-bit is the subnet field, and it allows 2 to the power 16 or 65,536 subnets. This number is redundant for largest corporations in the world. The 64-bit left, which is not shown in the above example, is the interface ID or host part. It is much more bigger, 64 bits or 2 to the power 64 hosts per subnet. For example, we have this IPv6 address, and an administrator can assign an IPv6 address as follows to a specific host or end user device. This one that we have over there. I'm not going to read it because it's a little bit extensive, but you get the idea. IPv6 address scopes. Address types have well-defined destination scopes. We have the global, size, and link. Let's go over the description for them. So first, let me just change to a green color for now. Link local address, only used between neighbors on the same link. automatic address configuration, neighbor discovery, router discovery, and many routing protocols. It is only valid on the current subnet. They are always automatically configured. Routers do not forward packets with linked local addresses are allocated with the FE80::64 prefix can be easily recognized by the prefix FE80. Some books indicate the range of link local addresses FE80::10, meaning the first 10 bits are fixed or link local address can be assigned, can begin with FE80, FE90, FE80, and FEB0, but in fact, the next 654 bits are all zeros, so you will see the prefix FE80 for the link local address, same as 169.254.x.x in IPv4, the APIPA address. It is assigned when a DHCP server is unavailable and no static addresses have been assigned. It is used. It usually created dynamically using the link local prefix of FE80::10 and the 64-bit interface identifier based on 48 bits MAC address. Only one link local address can be configured per interface. And there you have it, link local address. Let's go with the next one, and we are going to cover the next IPv6 address scope. Site local address or unique local address. They are analogous to IPv4's private addresses classes used between nodes communicating with other nodes in the same site, allow devices in the same organization or site to exchange data. Starts with FC:00::7 for use in private networks. The first octet can be FE, FC, or FD. However, when you implement this, you have to set the L bit, the rightmost bit of the first octet, to one, which means that the first two digits will be FD. Maybe you will be surprised, but site local addresses are no longer supported, deprecated by RFC 3879, so maybe you will not see it in the future. And finally, we come to unique global unicast address. Global unicast address. Okay, first, unicast packets sent through the public internet, equivalent to public IPv4 addresses. Global unique throughout the internet starts with 2000::4/3 prefix. This means any address beginning with 2 or 3, but the future global unicast address might not have this limitation. Okay, so let's go over with this one. All nodes must have at least one link local address, although each interface can have multiple addresses, which is different from IPv4 addresses, where each interface can only have one IPv4 address. However, using them could not also mean that NAT could be required and addresses would again not be end-to-end. Site local addresses are no longer supported. These are deprecated by RFC 3879. Okay, continue with this. We have special IPv6 addresses. FF00 ::/8 range is used for IPv6 multicast. The first octet is FF11111111. This way, we can tell at a glance if an IPv6 address is intended for multicast or not. In this range, well-known multicast addresses have the prefix FF:00::/12. This means that the first three hexadecimal digits of an address will be FF0. Reserved multicast IPv6 addresses are listed below. Now, we are going to go over them and understand a little bit about those. The first one, FF02::1, all nodes on a link local scope. Second one, we have the FF02::2, all routers on a link. Third, FF02::5, OSPF version 3, all SPF routers. FF02::6, OSPF version 3, all DR routers. FF02::9, all routing information protocol RIP routers on a link. FF02::A, the letter A, FF02::A, EIGRP routers. There you got it. Okay, now we have FF02::1 :FF XX 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 divided by another column over there. And what does it mean? All solicited node multicast addresses used for host, auto configuration, and neighbor discovery, similar to ARP in IPv4. The XX column XXXX is this one is the far right 24 bits of the corresponding unicast or anycast address of the node. FF05: 101. Okay, let's go with this one. All network time protocol NTP servers. Final note. When an interface is configured with IPv6 address, it automatically joins the all nodes FF02::1 and solicited node FF02::1 :FFXX :XXXX multicast groups. The all node group is used to communicate with all interfaces on the local link, and the solicited nodes multicast group is required for link layer address resolution. Routers also join a third multicast group, the all routers group FF02::2. A lot of reading, a lot of understanding, a lot of material, a lot of theory. I hope that you have enjoyed this lesson and learned a little bit about IPv6 addresses and their main functionalities and basics. My name is Cesar. It's been a pleasure. So take care, boys and girls. I will see you at the top of success. Until next lesson.